Well, hello there. This is a continuation of my couple last videos where I was talking about irradiance and how to make it equally spread on a surface using, well, in my case, fall lights. Since last time, I've updated the measure of success essentially, and it's basically a contrast ratio, which is the max of the value available minus mean value, and it's all divided by max, and you get this percent. So the smaller the number, the less variance, I guess, between the highest, the brightest, and the darkest point. And with these manually found measurements, I get 0.4%. So what I did since then, I did essentially optimization, where I gave it some constraints and asked it to find the best position of lights, their position in X, Y, and Z, essentially. And that's what it did. I believe over here these are the best coordinates it could find. And what it means is for the receiver plate at XY plane at Z equals 0, if you put lights at 2.2, 2.2, and then at this height, you will get best contrast ratio, which is 0.01%. So it's not even actual number, it is a percent, so it's very small percent. Now then I thought, all right, I'm curious so I'm looking for this contrast value, and for this particular position of lights you get this distribution of irradiance on a plane. Now moving lights around in one particular Z, how would contrast change depending on that? And that's what I did over here. So if for example take Z as an example equal 4, then on the level 4, so basically 4 units away from the plate, these obviously your winning spots, but if you move them around, over here for example, then you will get contrast ratio equal 0.2, so it's like a 2%, or here it will be very high, but in those points it will be much smaller. I think it will be, it will be that number that I showed you, or like similar. And then I thought, okay, so this is for just one Z equal 4. What if I look at different Z levels and see what happens there? And that's what I did with this one. And that is essentially going up in Z. These are the positions that you should put your light at to make best distribution of light with the minimal difference between min and max. You can see they seem like they are very linear. So there is a particular angle, it seems like they are going at. I can probably calculate that angle. I didn't check it previously. What I do know is for the best position I found, if you draw a line from here to here, then it will be 50.6%. So if I draw this line and I check the angle between this line and diagonal of the square, it will be 50 degrees. But I'm not sure if, probably they all meet in the middle. So that would be this angle. So this angle here is 50.5 degrees to the plate, to the Y plate. So if I put the 0 of Z at, they look like they will meet they will meet at the middle point at the origin. So yeah, that's my finding. Oh yeah, and the other thing you can see here is the color and the size of the ball. So the farther away from the plate you are, the better your contrast will be. Kind of obvious, like if you like, it's hard to put 4 lights close to the surface and get a well spread light. So the farther you go, the less error or less difference, less contrast you'll get. And that's pretty much it. Thank you.